think we can start. Welcome all. Thank you for joining us for today's session. My name is Neslihan Ivit. I'm the Winemaking and Innovation Specialist with Perennia. And today our co-host is Francisco Diaz. He is the Viticulture Specialist with Perennia. This is the second session of From Grapes to Wine Cool Climate webinars. And today's topic is the influence of the type of sugar used and the metal content on the flavor of sparkling wine. Before we jump into our speakers, I would like to give some Zoom housekeeping information. You all have your audio and video turned off during the session, but we encourage you to make questions to our speakers. And to do so, please use the Q&A feature at the bottom of your screen. And at the end of the presentation of our speakers, Francisco will be asking those questions to our speakers. A small introduction of Perennia. Perennia is a provincial development agency. Our vision at Perennia is that Nova Scotia is a recognized world leader in producing innovative, environmental friendly, safe, and high quality food. Our mission is supporting growth, transformation, and economic development in Nova Scotia's agriculture, seafood, food, and beverage sectors. We have a wide range of service areas, and we have agriculture, quality and food safety, product development, lab services, and fisheries. Our services in the wine sector starts from site assessments. We have also viticulture services, a plant health lab, winemaking services, mobile bottling and filtration lines, and business development services available. And today's topic is sparkling winemaking. And sparkling winemaking is produced everywhere in the world today. And in the production, there's a global increase to answer the high demand. And today in our session, we have a great audience from all around the world. So that's why I would like to start with a general overview of the Canadian sparkling wines. Sparkling wines are produced in Canada from coast to coast. Starting from the west, we have British Columbia, and moving towards the east, we have Ontario, where our speakers are located today in Niagara, and moving more in Quebec, and finally coming to the Atlantic coast in Nova Scotia. And Nova Scotia is well known with its white wines as well as sparkling wines. We use different methods to produce sparkling wines, including traditional method, Sharmat method, ancient method, as well as carbonation. Another important characteristic is in the grape varieties. We use both interspecific hybrids and Vitis vinifera to make still and sparkling wines. To give example to the sparkling wine varieties of hybrids, it could be L'Acadie Blanc, Seyval Blanc, Léon Milo, and New York Muscat. And in Vitis vinifera, it could be Chardonnay, Pinot Noir, Meunier, as well as Riesling. And when it comes to the winemaking of part of the things, there are a lot of parameters affecting the flavor and the quality. Every step from starting from viticulture practices coming to the bottling and aging has an impact. And especially in the traditional and Sharmat method, where you have two fermentations in base winemaking and sparkling winemaking. And in today's webinar, it's great to have the expertise of Dr. Belinda Kemp to talk about two important aspects for this, for the sparkling winemaking. Dr. Belinda Kemp is the senior staff scientist in Oenology at CCOVI. She has a PhD in Lincoln University, New Zealand. She has a vast experience in still and sparkling winemaking in New Zealand and in the UK. And she organizes Fizz clubs for all the Canadian sparkling winemakers. She is a member of VQA Standards Development Committee, and her current research focus is very wide, including sparkling wines, flavor chemistry, and different flavors in still and sparkling wines and phenolic management. And she has a lot of published articles. If you're interested in topics, I would invite you to take a look. And our second speaker is Hannah Charnock. She has a Bachelor of Science in Chemistry from University of Victoria. She has previous job experience as a senior quality analyst at Phillips Brewing and Malting Company, and also co-founder of Smoke and Mirrors Coffee Company. And she is currently a Master of Science candidate at Brock University, and she works with Belinda Kemp and Dr. Gary Pickering. She will be talking more about her current research focus today, and she is very passionate about science communication and improve research and accessibility broad and diverse audiences like we have today. So with that, I would like to thank both of our speakers to be here with us, and I will give the screen to Belinda. Thank you.
Thank you. Just bear with me one moment. We've got quite a lot to get through. Okay, thank you very much for that introduction. Can you hear me, Nestle? Is everything? Yeah, brilliant. Yes, so we've got quite a lot to cover today, some new information and some talking about the research that we've been doing at CCOVI. So I'm going to jump straight in after obviously thanking Nestle and Francisco for inviting us. So today we're going to be talking and telling you a little bit more about the Maillard reaction, or the supposed Maillard reaction, or the compounds associated with it. I'm also going to tell you a little bit about sugar degradation in sparkling wine and the sugars during production that are actively involved in producing these compounds. Hannah's going to share with you some really cool results with regards to the metals and why metals are important to sparkling wines, but particularly with reference to Maillard reaction. And she's also going to talk to you a little bit about the dosage trial with all the different sugar levels. So we've got quite a few things to get in today. For those of you who are winemakers listening, forgive me for a moment, but we do need to just briefly explain the two methods that we're going to be looking at are traditional method and Sharmat method. Hannah's going to talk more about Sharmat method, which is why we've included this in this diagram. I'm looking more at traditional methods. So we're going to be looking and talking about the sugars with regards to base wines, aging on lees, and then the disgorging or the dosage addition. But Hannah's also going to include some of the stuff with regards to Sharmat method, and just a reminder that is made or produced using a pressurized tank to produce CO2. I'm not going to delve too much more into the production because I think I'll be teaching people who already know. So I'll leave that there for a moment. This research is completely funded by NSERC, which is the National Science, Engineering and Research Council of Canada. And the whole project is a 5-year project, which is probably not even enough, to be honest, because it's just so many layers to it. But it's specifically looking at the Maillard reaction associated compounds in sparkling. And right there is one of the things I think we tend to get confused about with regards to the terminology. I think when we talk about Maillard reaction and sparkling wine, we really need to say associated, because some of these compounds come from other pathways and other ways that have absolutely nothing to do with the Maillard reaction, don't even need amino acids. So the Maillard reaction imparts both physical, chemical and sensory properties to sparkling wine, which you're going to see in a moment. And as Hannah's background has shown you, she has a background in Maillard reaction in coffee, whiskey and beer. So perfect to come and work with us at CCOVI with it in sparkling wine. But a lot of the current literature that's present deals with bread, coffee, grain, beer. Though there are some studies on Madeira wine, but again, those temperatures that wine hits is not the same as sparkling. But it's pretty tough to find much about sparkling wine and these compounds, particularly, or in fact, any low temperature acidic solutions. There are a couple, which I'm going to show you in a second. So just a reminder is that the Maillard reaction was first described by Louis Camille Maillard in 1912, bless him. It is a reaction between amino acids and a reducing sugar, but the key one that I've highlighted here is that it's during heating. It does result in browning, and we don't get anywhere near the level of browning in sparkling wine that heating produces at all. We know that it's non-enzymatic, but it can also include a whole range of compounds. So those sort of compounds that are involved are proteins, polypeptides, amino acids, and reducing sugars. I should just break that down even further and say that it's not just fermentable sugars, it's all those non-fermentable sugars, no matter how small amount they're in, that are also important. So I'm not going to go through all the chemistry with you. There's plenty of that available for you in the Maillard reaction, but I want to just show you that you can see the starting step, the sugar and amino acids. And in the second part, you'll see HMF, and this is the compound we're going to look at in a moment. What's really important here to show you is the Maillard reaction is not one thing, unfortunately. It's many, many steps. And I was reading a paper earlier this week, and if you just had a couple of amino acids and a couple of sugars throughout this whole process with heating, if it's heated up, you can end up with about 300 compounds throughout this whole process. And again, that's with higher temperatures. Depending on what temperature you go to, you can that will alter the types of compounds that are produced. So that's important. It's also one of the reasons why trying to accelerate aging to make the Maillard reaction in sparkling wine is so problematic. When you do that and you lift up the temperature 30, 40, 50, 100 degrees, you're just getting a bunch of compounds that would never even be there in the first place. The colouring, the brown colouring is also something we don't get in sparkling wine, not the sort of ones we're talking about. But you might do in this one, this article down on the bottom right, you'll see a paper about the 170-year-old champagne from the Baltic Sea. Now, I suspect at 170 years old, it probably was brown. But other than that, you're not going to get the sort of browning that we see elsewhere. There have been studies, though, on it, and this is what these are some shown here. I want to draw your attention to the one on the left at the top, which is from a group of researchers in Champagne. And they looked at base wines in a big champagne house that were held as reserve wines over 27 years. And some of the Maillard-associated compounds just increase in those base wines year after year after year. And so the highest are obviously found in the 27-year-old reserve base wines. Now, the Maillard reaction produces a whole heap of different compounds, and these will depend on the temperature used, which I've just mentioned, the pH as well, but it also will depend on the types of amino acids and which amino acids make which compound with which sugar and the types of sugars. But basically we end up with roasted caramel, nutty and toasty flavors and maybe some others, which I'm going to explain about. But if anybody's further interested in looking more into the actual compounds within sparkling wine, or you have any questions that we don't manage to cover today, then do give me do flick me an email or to Hannah an email. I'm more than happy to send some information to you. One of the difficulties is a lot of these papers, not all of them, but a lot of the papers are under paywall, so not always accessible to people to see. So, right, sparkling wine, Maillard reaction, temperature I've mentioned, pH I've mentioned, the composition of the wine's really important, time is of the essence, and it's really the biggest thing in sparkling wine that produces these compounds. But other factors can negatively or positively affect it. So a simple thing would be what type of nutrients you add to your base wine for your second fermentation. If you add a nutrient that has a high level of amino acids and they're not all going to be used up, some will, but they're not going to all be used up during second fermentation, then you're essentially adding more amino acids for the reaction. On top of that is the types of sugars. Some sugars are far more reactive than others. It's the type of yeast as well you use that release different types of amino acids. And then it's the organic acid profile as well. So how much tartaric you have, whether you've got malic in there, because tartaric really helps generate the compounds to be generated in sparkling. Pressure is really important. The higher the pressure, the more of the compounds, but again, over time. I'm going to keep stressing over time. And then So2 levels is a funny one. It's only funny in that we're not entirely sure how that works and how much it is problematic, if any. And bearing in mind that during first and second fermentation, we tried to keep it a minimum, not entirely sure how important that really is for us. So there we are. We've got our low temperatures, our low pH, probably around 3, probably 3.4. It's a bit high there, and high, what we call high acidity. So the organic acid positively impacts the formation and stability of compounds. That's well known. What else is well known is that compounds that are associated with the Maillard reaction in sparkling wine, where people think come from the Maillard or talk about coming from the Maillard, are actually just formed from the degradation of sugar, and you don't even need an amino acid for those compounds to be made. And there's studies that have shown this already. So this isn't information coming from my lab, unfortunately. So it's catalyzed by high acid, and one of the major compounds that has been studied a lot and continues to be important is the compound I mentioned, 5-HMF, which I'm going to talk about in a moment. It's a bit of a long name. So here, 5-hydroxymethylfurfural, which is why I say 5-HMF, is basically a compound that comes from furan, and it's made from sugar degradation. It comes predominantly from fructose being degraded in acid solutions. So fructose is the most reactive of all the sugars. And you'll see here, you might see here down on the screen on the right-hand side, the comparison between glucose and fructose. So you can see that that's more of an open structure at the top there. The thing about fructose that makes it so fascinating as well is the sweetest of the sugars. So it's much sweeter than glucose. So if winemakers can try this, if you do a dosage trial and you pop a couple of grams per litre of fructose only into one, glucose into another, and then sugar and glucose combined into another, just for a trial for yourself over time, go back and keep tasting, you'll be able to see just the difference the fructose alone makes. I'm not suggesting anyone goes and change all their dosages to fructose. What I'm saying is just taste the difference. So we know that 5-HMF is produced in all sorts of ways from fructose, sugar degradation pathway, and from the Maillard reaction. So it comes from two pathways. But a whole bunch of other sugars that are not fermentable, that are in wine, that we don't take an awful lot of notice of, but are actually play an important role, are things like arabinose, xylose, ribose, and rhamnose. Now they're the main non-fermentable sugars in sparkling wines, but arabinose can only come from the grapeberry. It doesn't come from anywhere else. And that and ribose, actually all four of those sugars are active in the Maillard reaction, but also can actively be degraded in acidic solutions to produce this family of furan compounds, 5-HMF, furfural, all these sort of things. And of course, these compounds are also in things like coffee where they are heated up. So there's two pathways there. You can, if anybody wants to look further into this, you can look up the fructose degradation pathway that forms 5-HMF online. I'm not going to go through all of that. So this compound gives you caramel, musty, waxy, and at high levels in beer can sort of give a stale character to beer. At very high levels, much higher levels than we would ever get in sparkling wine or even Madeira, it can be carcinogenic, but we don't just to reassure you, we never reach those sort of levels. Now, the other difficulty with these sort of compounds, and particularly 5-HMF, is it's extremely unstable. So when we buy it and store it, even in the lab, it doesn't have a very long shelf life. I think it's literally a couple of weeks, which makes it not only expensive to work with, but more importantly, very difficult to find out what its odor threshold is, or where, at what level of concentration you can detect it in wine, because it is just so unstable. And doing sensory analysis of that kind, odor thresholds on one particular compound that's very unstable, is just going to take, it's going to be A, be extremely difficult, and B, take a very long time. So we don't actually know at what concentration it's detected in humans. There's nothing anywhere. And certainly not just in wine, but also in beer or other things. And the thing about detection levels and odor thresholds that's so interesting is that you can have a tiny amount of a compound, but it's extremely potent. So you could smell it really easily at nanograms per litre, a bit like the methoxypyrazines. So it could be that at a certain amount, we can detect it, and we don't know what that is. Now, there are other furfural compounds that are a bit more stable, and we do know what those detection levels are, but there's not many of them. And this is another huge area that really needs going into depth and investigating, and which is also challenging, as I said, to find out, well, there might be tons of a compound, but actually doesn't contribute much, or there could be a tiny amount, but because its threshold is so low that you detect it straight away. Human nose will detect it straight away. Now, so with all that going on, let's just have a look at the stages of traditional method. Do Maillard reaction compounds happen during the first, or produced during the first fermentation? Somebody asked me this the other day. Absolutely no idea. It's never been studied. I suspect there's much more going on. And again, the temperature is so low. There's also the amino acids are being used up to produce esters, which they continue to do, of course, during base wine aging. And so we're not entirely sure, I guess, in one way, by measuring it, these compounds before and after primary fermentation would probably be the easiest way to do that. The second thing is base wine. Now, as I mentioned just now about the big study in Champagne, over 27 vintages from the big Champagne house, we know that some of these products from sugar degradation, but also from Maillard, the Furan family, are being produced in base wines the longer you age them. So we have in those base wines, those arabinose, xylose, ribose, rhamnose, and you do have fructose in there. Fructose being the most reactive, remember, and that will degrade first, more than any of the first before any other sugars. So if you think at the end of primary fermentation and you analyze the wine for fructose, even though it says dry, you can still have 3 grams per litre of fructose, but no glucose, because obviously the yeast are taking up the glucose first. But that 3 grams per litre, or 1 or 2 grams per litre, you leave the base wine aging, is still going to be reactive and still degrade. You've still got the acid in there, you've still got the low pH, you've still got the perfect environment for that to go on. Plus, on top of that, all those pentose sugars, again, even though they're in small amounts, are still degrading. The grapeberry, the arabinose, the xylose, the ribose and rhamnose. I put mannose in there with a question mark because mannose actually comes from yeast cell walls. And so it will depend on how long you are aging your base wine on lees. And again, it goes back to this thing about base wine aging for up to 27 years from that particular paper. But the mannose is obviously the sugar that is in the cell wall of yeast. So it will depend how long that base wine aging, how long you age on lees as to whether that's how much of that is released. Again, we know that mannose is also very reactive and does get involved, or is involved, I should say, in the Maillard reaction associated compounds, and does does produce compounds as well. So all those sugars in those base wines, even though they're at small amounts and we don't measure as winemakers and even as scientists, we don't spend much time on these non-fermentable sugars in sparkling wines. But the likelihood is, and from studies we already know on base wines, that all these sugars are involved in producing these these compounds during base wine aging. Then you've got the aging on lees, and now you've still got all those sugars, but now you've also got more mannose, because you've got each individual bottle with its yeast cells going through autolysis. Then you've got amino acids being released, the peak of which happens around 12 to 18 months. And then that starts to decline. The free amino acids start to decline. But the likelihood, and why that's probably happened, is because they're getting so involved in all the other compounds being produced. So esters, for instance, between an amino acid and an ethanol. But also these kind of Maillard reaction associated compounds. So the autolytic characteristics that are coming from that age leasing are also coming from these sort of sugars that are being released, the amino acids being released, and that side of stuff. And of course, you've got other things like your manoprotein. Well, sorry, that's, yeah, other things that are in there.
Belinda?
Oh, yes.
20 minutes, 20 minutes.
Thank you very much. I just finished the last bit. I've only got a couple more slides. So disgorging, now you've added in, on top of all those sugars and the mannose from the yeast, you now added in glucose and fructose if you're using cane or beet sugar. Hannah's going to talk a little bit more about that. Or one or the other, or whatever you're using, but you have got glucose in there, but still fructose is going to react first to produce those. Now, when we do dosage and disgorging trials, we have to do it longer than the 3 or 6 months, not just winemakers, but we have to, as scientists, what might taste fabulous after 3 months, 2-3 months, 6 months, 12 months down the line will take on, or could take on, completely different characteristics, depending on the source of the sugar, the type of sugar, how it was produced, and a whole range of things, or even the wine that you've actually used in the dosage. So that's just a heads up for winemakers who I'm sure you take up to 6 months before you decide on a dosage to see how it develops. But just in case, those who are new might not realize. Okay, so we've covered that quite quickly. We have a lot of work underway on another element of it. One of the things in sparkling is the presence of hydroxycinnamic acids, which are the majority of phenolic compounds in sparkling. We know that one of them promotes it, and we know that another hydroxycinnamic acid prevents it. So we're just having a look to see how that works and which one does what in base wine particularly. And then we're using some really cool innovative processes that have never been used in winemaking before to look at the impact of what we refer to as Maillard reaction products, but we should put associated in there just to be correct. So that's being done by Jacob, who's bravely joined us in the middle of a pandemic and is in the lab. And Andrew is working on the difference between cane and beet sugar on the different compounds that are produced and the flavors that are produced by those two sugars. So I'm going to hand over the stage now to Hannah.
Thank you very much for the introduction and for having me here to share this research. So today I'm going to be talking about 2 key experiments as part of my master's research, which relate to Maillard-associated compounds in sparkling wine. The first being the type of sugar used at liqueur de dosage on the formation of these products during aging in traditional method sparkling wine. And then secondly, the metal composition of commercial sparkling wines across the Niagara region. So we're aiming to see if these wines can be differentiated based on metal composition by region, style, and production method. So first of all, sort of going back to those factors that impact Maillard activity, This evaluation of sugar type is looking at both the reactant composition, so the structure of these sugars and how that plays into the formation of Maillard-associated products, as well as time. So, sorry, I'm just going to move somewhat quickly through these because I know we're a little bit tight on time. The idea of looking at the dosage stage is because we know that during the second fermentation in bottle in traditional method sparkling wine, this aging on the yeast cells following fermentation leads to the yeast autolysis, liberating various proteins, peptides, and amino acids. And this begins between 2 to 4 months after the completion of second fermentation, which is good news for us because in Ontario, vintage dated sparkling wine can be aged on lees for no less than 12 months. So we know that we're sort of working with a window where there will be the liberation of a lot of these starting material compounds for the Maillard reaction. So in terms of how this relates to sort of the experimental layout, up top here, we can see the production steps in producing traditional method sparkling wine. So again, the focus here is on dosage, or that final sugar addition to adjust for desired sweetness, as well as to make up any lost volume during disgorging. So at this second fermentation and aging period, we have the release of amino acids and proteins and polypeptides, and then subsequently the addition of the sugar component, hopefully seeing that those two can interact in a sort of a variety of different ways to produce flavor active species. So in this sort of aging experiment, it's still very much underway, but I just sort of wanted to give you guys a little bit of information about what research we're currently carrying out. This was done with commercial sparkling wine that was riddled and disgorged, provided by Niagara College. It was a 2015 vintage that had 3 years of aging on lees. So at this point, we are confident in the release of these amino acid products, and we can quantify those as well. Dosage treatments are by sugar type. So we have 6 different sugars that we're looking at, as well as obviously a control, looking at the difference between glucose and fructose, where glucose is, as Belinda mentioned, a hexose monosaccharide or single sugar unit. That's a 6-carbon structure, fructose being the pentose or 5-carbon structure of a monosaccharide. So in addition to those, we're also looking at sucrose, comparing cane sugar versus beet sugar. And this is essentially to sort of provide some scientific legitimacy to a lot of sort of industry knowledge that there's some sensory difference between the two. So our aim is to sort of investigate this and find out how sucrose as a structural sugar disaccharide interacts in these reactions. We're also looking at maltose, which obviously isn't found in grapes and wine, but it is a disaccharide of 2 glucose monomers. And in the work that I was involved in previously in industry at a brewery, we were looking at maltose and the Maillard reaction, potentially seeing how those 2 glucose monomers could be sort of separated and then react. And then our final sugar that we're looking at here is a commercial product of rectified grape must concentrate, which is essentially a 1-to-1 ratio of glucose and fructose monomers, which is used by a lot of commercial producers, and trying to see how that product relates. So the idea is to do time course sampling at sort of our time 0 interval, find out what is in our starting wine, as well as right after the sugars are added, and then at intervals of 8 and 16 months. So our next sample interval is actually coming up. So this is sort of just to give an overview of where we're at. The analysis of these wines is obviously taking into account standard wine chemical analysis, as well as looking at sugar levels by an enzymatic assay and amino acid levels by capillary electrophoresis. And this allows us to monitor the levels of these starting materials throughout the aging process. And then finally, and most importantly, looking at the Maillard reaction product formation and quantifying that by a gas chromatography mass spec technique. So in comparing sugars, as I mentioned, we're looking at the differences between cane sugar and beet sugar, and how those potentially can drive different flavor product formation. So we carried out a sugar purity analysis by HPLC with Chem Labs in Toronto. And we found that the percent purity of both cane sugar and beet sugar is identical at 99.9%, which is also of higher purity than the other sugars that we're working with. So basically what this tells us is that any differences that may arise in terms of volatile profile can be attributed to that 0.1% of impurities. And what those impurities are, we aren't exactly sure, but that's what Andrew's work is sort of hoping to find out, and to find out how those potentially relate to different aroma properties. And then finally, an interesting note regarding this is that we were able to sort of validate the composition of the Mcr sugar, which showed slightly higher glucose than fructose percentages, just sort of telling us how potentially these species can interact to form Mcr products. And then also of note is that the Mcr product detection that we're working with mass spec is looking specifically at compounds that integrate amino acids and sugars. So in this research, we aren't looking at those compounds that are the result of sort of single sugar degradation. We're instead looking for sort of various heterocycles that incorporate things like sulfur and oxygen and nitrogen that are derived from the amino acids themselves. And then we don't have many results for this so far, but I just wanted to discuss this, this index or measure of Mcr activity that's commonly used in literature, which Belinda mentioned earlier was sort of this idea of browning. And the degree of browning absorbance metric is commonly used in literature in heated systems to measure the formation of advanced Mcr products, things like melanoidins that can contribute color to the system. And in sparkling wine, we know that we don't have the heat to sort of drive the reaction to that point of producing those products. However, we still wanted to check to see how browning is playing a role in this study. And interestingly, at our 8-month time interval, which is the light blue bars here, we see that in some of our treatments, we're seeing a slightly higher of one or the other in terms of our degree of browning. Within cane sugar, we see some significance in the difference here. However, we won't know if this is just sort of related to oxidation or if this is a pattern until we get our final time interval point. But with our control, we do see a significant increase in the degree of browning between our time 0 and our 8-month trial. Again, we won't really know if this is a trend or sort of variability between our samples until we have our final interval. But this could potentially be an indicator that sugar could provide some protective properties to the wine in terms of oxidation. So these 0 dosage wines may be more prone to a slight increase in this degree of browning, which, as I mentioned in this study, is not necessarily a metric of Mcr activity, but rather just monitoring the color of the solution. So the results of this, as I mentioned, are currently still underway. Our final interval is late March 2021. So we will have more results for this later this year. And we're aiming to see how the formation of Mcr reaction products or Mcr associated products are linked to the rates of sugar type and amino acid levels during this study. And the aim is to try and infer from the compounds that are being produced and the decreases in various sugar and amino acid levels to try and make some understanding of possible chemical reaction pathways that take place under these sort of unique sparkling wine physiochemical conditions of the low temperature and the acidic environment. So that one I just sort of blew through quite quickly, but I want to spend a little bit more time talking about our metal ion content survey of Niagara Peninsula sparkling wines. So here we wanted to establish the metal composition of sparkling wines in general. There's very little literature relating to that, especially within our region, because we know that metal composition is quite closely tied to geographical origin. So background on why we're interested in this is we know that metals can play a role in driving Maillard activity. This was identified in an industry study that I took part in, looking at the influence of magnesium on the Maillard reaction in brewing system, looking at a maltose and amino acid system, which sort of prompted the use of maltose in the previous dosage study. So understanding where metals come from in sparkling wine is important in order to try and infer how that relates to flavor. They can come from various natural and anthropogenic sources. We know that a large majority of the metal ions are derived from the soil, whether that be from soil composition itself or related to water resources, climate, agricultural practices, different things like that, as well as strategies within the winery itself. For example, the use of different types of materials for fermentation tanks and pumps and that kind of stuff, as well as additives and processing steps. And then of importance with this is we know that metals are primarily held within the grape skins and seeds versus the pulp. So this would sort of lead us to believe that we're anticipating a higher level of these vineyard-derived metals in rosé or skin-contacted sparkling wine production or wine production in general. And this is verified in the literature of still table wines comparing red versus white versus rosé. We see that with increased skin contact comes higher vineyard-derived metal levels. And then looking at the geographical distribution, we wanted to find out how and if we can try and separate metal composition of sparkling wines within this area. Due to the regional specificity of soil-derived metal composition and sort of the absence of literature relating to the Canadian wine industry, we wanted to investigate this. And this is, again, just of note, these are looking at sub-appellations that are designated by the VQA Ontario standards, because that's how these wines are labeled. So it sort of makes it easier for us to use these as regional discrimination areas. So we analyzed 28 metal ions by inductively coupled plasma mass spectrometry, and a couple elements were over that linear range. We used inductively coupled plasma optical emission spectrometry. As I mentioned, we categorized wines based on region, production method, and style, and the levels of metals in all wines were below internationally regulated standards. So this is our distribution of wines by traditional method on the left and Sharmat method on the right. And within that, looking at rosé versus non-rosé style. The higher proportion of traditional method and non-rosé wines is approximately reflective of sort of the local industry's production trends as well. So some interesting results. So between comparing production method of Sharmat method versus traditional method, we see an increase in strontium content in Sharmat method wines. However, because strontium is soil derived or vineyard derived, the reason for this increase is kind of unclear at this point. We're continuing to investigate that. There's no literature on the role of strontium in Maillard activity. However, it does have the same valency as magnesium, which was shown to drive Maillard activity in the beer brewing study. This oxidation state of +2 might mean that it can play a role in the Maillard reaction in wine as well. And existing literature looks primarily at using strontium stable isotope ratios to geographically discriminate wines. And we know that wine production method has no impact on that isotopic ratio, but literature does suggest that increased concentration is related to maceration. However, we didn't see that as being consistent with our rosé versus non-rosé trials. Secondly, by production method, we see an increase in boron in traditional method wines. Boron is an essential micronutrient for plants and animals. It's related to various health considerations. And wine is considered to be a top contributor of dietary boron intake. This increased boron content, again, is kind of a mystery in terms of it being primarily derived from the plant itself. So the increase in traditional method wines wasn't consistent with anything related to skin contact. But we do know we do know that in the literature, there's no links to boron in terms of Maillard activity. So this is more of a finding that relates to strictly production method rather than anything Maillard related. And then finally, and of significant interest from this study was the increased chromium content in Sharmat method wines. It wasn't detected in all samples. We had about 24 of the 73 samples that were below limit of detection values. Chromium is considered to be a trace micronutrient and can be derived from various origins, including soil and environmental factors. But here the focus is that it may be linked to leaching from stainless steel, where it's used as a protective coating to prevent oxidation. And this is consistent with the tank contact during production for Sharmat method wines. There's no internationally recommended or regulated maximum limits of chromium in wine, but our survey found higher levels in one of our wines than was previously identified in sparkling wine literature. The highest range previously was 36 parts per billion in champagnes, and we found a 43 part per billion sample, which isn't majorly outside of that window, but is of note. And just to sort of point out that this second fermentation in tank is the likely source of chromium in producing Sharmat method wines. And then finally, I'll just sort of quickly go over these last few. I know we're a little bit tight on time. Looking by production style, which is non-rosé versus rosé, we see that the rosé wines have a significantly higher level of potassium and total metals, which is consistent with what we understand to happen during skin maceration. Potassium is the most abundant element in wine, and this increased extraction is explainable by the skin contact, as well as the extraction of total metals overall. We aimed to see if we could discriminate wines based on VQA subappellation, as I mentioned, these sort of geographical borders within the Niagara region. However, only traditional method wines are able to have a subappellation designation by the VQA. So those were identified here as rosé or non-rosé, with the rosé being the green data points in the PCA here. And we find that we have somewhat minimal discrimination between some of these regions, which is likely both linked to a low number of wines per region to achieve separation, as well as the small geographical area within Niagara that we're trying to distinguish between. So this is somewhat inconclusive at this point, but will be an area of future study. And future directions, looking at the role of liqueur de tirage on aging following second fermentation, looking at the role of sugar type here and how that contributes to the formation of Maillard products, and how to differentiate those from autolytic characters. And then secondly, which is part of sort of our ongoing work in the metals area, is looking at kinetic pathways leading to the formation of Maillard products under these unique sparkling wine conditions. So looking at how metals may participate in the formation and stability of Maillard products in model systems, and then considerations for those levels on undesirable reactions like haze formation and off flavors and impacts on acidity. And then a very quick summary that our dosage study is looking at strategies to alter flavor profile is essentially the outcome that we're anticipating, is to see if specific sugar types can affect flavor. And examples of sort of applicable outcomes to winemakers may be things like cellaring finished wines for a period of time to optimize flavor development, and or selecting for a specific sugar in preparing the dosage solution. And then secondly, that monitoring metal levels during winemaking is an important aspect to wine quality. So specific attention to production steps that can impact this profile, including the type of process you're using, whether it be the chromium content in Sharmat method wines due to tank contact, or increased potassium with extended skin maceration, and implications for things like pH and flavor profile, of course. And then finally, the influence of metals on the Maillard is currently under investigation, as I mentioned. And thank you to all of our collaborators and funders and different aspects of this research. And I will stop sharing my screen.
Thank you, Hannah. Was perfect.
Thanks.
we have some questions. So the first one is for Belinda. How does the quantities and types of sugar vary across different varieties?
When I was talking about different sugars, I was really relating to what sugar you're using. But sugar content with different varieties, I don't know. I guess you'd have to think about the time of maturity. Obviously, the glucose and fructose doesn't differ that much in grape berries, but with regards to things like rabinos that come from the grape berry, then I'd have to have a think about that. I'd have to do a look around. I mean, all the work we're doing is really basically Chardonnay, Pinot Noir only. Actually, we're not using Pinot Meunier. So I can have a look, and we can include some numbers for that in later figures. Or I think that was Jonathan Rodwell. So I could always you can send me an email, Jonathan, and I'll have a look for you.
Very good eye, Belinda. Next question. How do oxidase and Maillard reaction impact browning in contrast?
That's for Hannah, obviously.
Yeah, I could talk about that. We're looking at, so yeah, as I mentioned, that sort of absorbance at 420, looking at the degree of browning. The aim of looking at that absorbance is specifically for the formation of melanoidins. That's sort of the range where you can detect the color brown. However, as I mentioned, that's sort of confounded by whether it's oxidative browning or melanoidin formation. And since we know that melanoidins aren't formed in sparkling wine, that to us is essentially a metric of oxidation, or anything else that can sort of contribute to color change within the wine, which right now oxidation is sort of our primary candidate that we're looking at.
Perfect, thank you. Other related question, and I suppose this will be for you as well, Hannah, is
Yes.
How does potassium impact wine?
Yeah, so in the most sort of interesting way that I'm familiar with in the literature is that increased potassium content can lead to an increase in the precipitation of potassium tartrates, which in turn can lead to an increase in pH, which is not necessarily what you want. So with skin contact winemaking, that's sort of an area that's being covered in the literature quite thoroughly, looking at how extended skin contact, extended potassium extraction can impact your TA and pH values.
Thank you. Following question is, are different metals directly testable?
Do you want to take that, Belinda, or do you want me to?
Oh no, you can take that one.
So yeah, it's interesting. Right now, sensory literature that I'm familiar with suggests that there is some taste receptor genes associated with divalent and trivalent metal ions. But in terms of that being different metal to metal, that isn't necessarily the direction of the literature that I've seen. It's more looking at how that state of the metal impacts the interaction with our taste receptors. So it sounds like there can be some impacts in terms of astringency and a metallic taste, and I think bitterness as well. But again, it can also have other impacts besides just taste, like it can impact haze formation, and that haze can impact mouthfeel. There's sort of a lot of things that it can do to impact sensory overall.
Thank you. Next question. It's quite long, everything, but I will read anyway. So fascinating. Nice to see Nova Scotia on the sparkling wine map. We normally associate the Maillard reaction with heat treatment. In the absence of heat, are you saying that it is basically the degradation of sugar in an acidic environment that acts as a substitute for heat to produce the necessary Maillard reaction?
I'm going to jump in, and then Hannah might have something to add here. I'm not making it as simplistic as that. I'm saying both are happening. There is definitely sugar degradation going on. There's no doubt the studies have shown that as well. There are compounds that do need an amino acid though, and that's what Hannah's looking at. There are two things there. One is catalyzed by acid, so I suspect in the absence of heat, it's acid. And the other thing is time. Time is of the essence, as I said, and the length of time is so important. So those two combined, the acid and the length of time, are really the main generators of it. But as we're going to find out with Hannah's work, we suspect that things like magnesium and calcium might also be playing a role, a bigger role than we initially thought of. You have varying amounts of magnesium from year to year in sparkling wines, and much so, and that's similar for calcium as well. And we tend not to think about those ones quite so much, but I suspect they're playing a much bigger role than we initially gave them credit for. Hannah, do you want to add anything to that at all?
Yeah, just to touch on the time concept, we know that even in like biological systems, like within our body, where there's an abundance of sugars and amino acid, at some point the Maillard reaction happens. And I think it's in our eyes. There's a lot of literature on that, where it just sort of over time, despite the lack of heat, those things just interact and occur. So essentially that's sort of what the aging component is looking at, is when they just sort of give in and actually interact.
Thank you very much. We have the last two ones, okay, and we are short of time, so this will be the last. This is, I don't know, it's a basic question, but anyway, I will ask, how is a dosage built up?
Hannah?
Do you want me to talk about that? So in my studies, we're taking the wine, like a base wine, we're adding sugar to it with a lot of time before it is added to the wine itself, because we know that it takes some time for that sugar to both dissolve and sort of equilibrate within the wine, whether it's sucrose breaking down into its monomers or sort of whatever that looks like. And then adding sulfur to prevent oxidation when it's added to the wine. And that was sort of the process for us, was building it up beforehand and making sure that it's stable before adding it.
Thank you, Hannah. This is our request, even though, just to let know to everybody here, this session will be, it's recorded and it will be shared with everyone, but is it possible to get a copy of the two slideshows? Because somebody would like to revisit the information slow time as well.
I'm quite happy to share mine. I just want to check with Hannah, because some of her stuff is yet to be, actually, I think some of that's got to be, is in the process of being published though. So how do you feel?
The metals data is, I'm okay to send it as is, sort of with the caveat that it hasn't been peer reviewed, and
okay,
will be at some point. Yeah, so there will be updates.
That's in the process of being published as a big paper. So just to be aware.
Okay, perfect. Yes, and I would like to repeat, the session has been recorded and it will be shared with everyone after getting the edits. Thank you very much.
Thank you for having us.
Thanks for having us.
Perfect.
Take
Thank
care.
you very much. I would like to invite you for our next session. It will be in February 11, 2021. It will be with Dr. Basile Potier, where he will be talking about the Comité Champagne and the spring frost in Champagne, and he will be sharing results from 100 years of research. And if you have any question, please feel free to reach to us and send us an email. And also we will be sending you a survey. We really appreciate your feedback on that, about the sessions. And we will be also sending you the link for the session. And finally, I would like to also invite you for the digital series of the Minister of Agriculture. This will be starting in February until April, 5 different sessions about agriculture in different topics. And for more information to that, please visit Perennia's website. Thanks again and have a nice day.